This is a video lesson on solving systems of equations using substitution. Let's take a look at the equations we've been given in this system. Neither of these equations are written as x equals or y equals, so that's always our first start when we're trying to solve using substitution. We need one of the equations to say x equals or y equals. So we want to look for the easiest way to do that. So let's look at equation number 1. Equation number 1 has a coefficient of 5 for the x term, so it's not going to be really easy to get the x by itself because we'd have to divide by 5, and neither -6 nor -1 is divisible by 5, so that will result in fractions. So we want to avoid that. So let's look at y. Again, the coefficient is not 1, and dividing by -6 isn't going to be good and will give us fractions also. So equation number 1 is out. Let's look at equation number 2. Equation number 2, the coefficient of x is 3 and the coefficient of y is 9. So it doesn't look very good that we can do either of those easily either. However, if we take a little closer look, if we divide by 3, if we get the x by itself and divide by 3, 9 is divisible by 3 and so is -30. So if we get the x by itself, we can actually do that pretty easily because dividing by 3 will not result in fractions. Now, if we looked at 9 here, dividing by 9 would result in fractions because 3 divided by 9 is a fraction, -30 divided by 9 is another fraction. So let's take equation number 2. So this one's a little unique here. So we're going to take equation number 2 and actually solve it for x. So in order to solve it for x, we want to get that x term alone, so we're going to leave it alone, get rid of that y term. So we will subtract 9y from both sides. That zeroes out the 9y on the left side, leaving us with just 3x equals, and then these are not like terms, so we cannot combine them. So we just write them side by side. So -9y and then -30. Now to get x all by itself, we're going to divide by that coefficient of 3. And like I said, this one's not going to end up in fractions. So we have x equals, and then we have to do -9 divided by 3, and that's a y term, so it's -9/3 y. And then minus, and then we have to do 30 divided by 3. So notice instead of treating this as -30, I just did minus and treated it as a +30. Now the only reason I wrote it out like this is to make sure you can see what I'm doing here. This step right here is not necessary. You can just go ahead and do -9 divided by, -9y divided by 3 is -3y. So that's the same thing if you went from here to here. And then we can do -30 divided by 3 is -10 or just -10. And again, that's the same thing as if we just took this right here, 30 divided by 3 is 10, and we're subtracting it. And there you go. We have an equation that has x all by itself. So that wasn't so bad, and it just happened to be that it worked out. If it didn't, then we would have to just deal with the fractions. Or actually, we could solve using a different method that we have not learned about yet. So that'll come later. Okay, so I also want to show you that you could have just in the very beginning, before even like doing this step right here, you could have taken this equation, and this is what you'll do a lot of times in algebra, is just divide by 3 at the start. So divide by each side by 3, and then you have to divide each term by 3, just like we did over here. So 3x divided by 3 is x, and then plus 9y divided by 3 is 3y, and then equals -10. So you could have taken that equation and divided by 3, or like reduced the equation to start, and then you would just finish solving for x by subtracting 3y from both sides, and it results in the exact same thing that we got over here. So either way is fine. It doesn't matter which way you do it. Again, this is the way you'll probably do it most often in algebra. Just because there are times when you're going to have to write in what's called standard form. And standard form, like this, would not be acceptable. It'd have to be reduced is kind of what we think of it as. So then this would be your final answer in a certain problem for algebra. So you'll get used to doing things like this, so this might be the method you end up doing when you're solving systems using substitution. Okay, now we can finish solving here. So now that I know that x is equal to negative 3y minus 10, I'm going to take that expression, since it's equal to x, and I'm going to substitute it in for x into the other equation, because I know that's what x is equal to. Okay, so I'm going to write equation number 2, or number 1. So 5, and then instead of x, I'm going to write that equation, or that expression that x is equal to, which is negative 3y minus 10. Close my parenthesis, and then finish the rest of the equation. Minus 6y equals negative 1. Now that we have parentheses, we know we have to use the distributive property. So 5 times negative 3y is negative 15y. 5 times 10 is 50, but you're subtracting it, so it's minus 50, or you can say you're adding a negative 50. Finish out the rest of the equation, so minus 6y, and then equals negative 1. Now we do have like terms in this one, so let's look at those. Negative 15y and negative 6y. So since they're on the same side, we just combine them, or like add them. So negative 15y and negative 6y combined is a negative 21y. And then you still have the minus 50 equals negative 1. So again, these are on the same side, so you're not adding 6y or adding 15y. They're just what they are, and you combine them. Okay, now I've got all the terms with variables into one on the left side, so I have to get rid of everything else. So I'm going to add 50 to both sides, and that zeroes that out, leaving me with negative 21y equals 49. And then, oh boy, you can see that this isn't going to work out very well. It's not going to be a whole number answer. But guess what? That's okay. It happens sometimes. Now, all the ones that we usually do have not had fractions or decimals, but this one does, and that's okay. So let's finish it. So we do want to do the same steps. So since this is multiplication by negative 21, to get rid of it, I'm going to divide by negative 21 to both sides. So since this is a decimal answer, we want to see if it's going to repeat or if it's going to terminate. So if you type that in the calculator, you'll get 2.3 repeating negative. That's a repeating decimal, so we're not going to write it as a decimal. You cannot write it as a decimal. We have to write it as a fraction. Otherwise, if we use an estimated answer when we solve for the other variable, it's not going to work out. So let's go ahead and just write this as a fraction. So it is a negative number because it's a positive divided by a negative. So I'm just going to write negative and then 49 over 21. So we do want to reduce it if possible. So what's a common factor between 49 and 21? The answer is 7. So we're going to divide each by 7. Because what you do to the numerator, you have to do to the denominator in order for it to still be equal. And so that leaves us with y equals negative, and then the negative's already taken care of. So then 49 divided by 7 is 7, and 21 divided by 7 is 3. And so it's y equals negative 7/3, and that is equal to negative 2 1/3. But again, we have to leave it as a fraction. And we could write it as negative 2 1/3. That's a mixed number, that's okay. But it's going to be way easier to deal with it when it's an improper fraction. And for sure, we're not going to write it as a decimal because the decimal is repeating. And you guys don't really know how to work with that very well when you're plugging it back in when you have a repeating decimal. So that's why it's so much easier just do it with a fraction. Then you don't have to worry about it. So you're not allowed to write it as a decimal. So let's go ahead and solve for the second variable. So I know y is equal to negative 7/3. Now I get to choose either of my original equations to solve for the second variable. I'm going to choose the first equation. So let's go first equation, which is 5x minus 6. Now instead of y, we're going to put the improper fraction version of our answer, so negative 7/3, and then equals negative 1. So 5x, and now I'm going to go ahead and know that this is going to be a negative times a negative, so that becomes a positive. So adding a positive. So this is going to be plus, and then I'm going to write 6 as 6 over 1. since I'm multiplying it by the fraction 7/3. Now I'm just going to keep multiplying. So you can cross reduce here if you want, or just multiply across. I'm going to go ahead and multiply across. So 6 times 7 is 42, over the denominator, 1 times 3, which is 3, equals -1. I'll go ahead and show you what it would look like if we cross-reduced. Since this is multiplication of two fractions, I can reduce a numerator and a denominator if they have a common factor, which is 3. 3 divides evenly into both. So I'm going to divide by 3 gives me 2, divide by 3 gives me 1. And now my number here is 2 times 7, which is 14, over 1 times 1, which is 1. So that actually equals 14. So that's the same thing as if I went down here and I did 6 times 7 is 42, 1 times 3 is 3, and then if you get a calculator, 42 divided by 3 is 14. So it's plus 14. So 5x plus 14 equals -1. Great, now there's no more fractions, so I can just finish solving pretty easily here. So I'm going to subtract 14 from both sides, isolate that term with a variable, so that zeroes out, and we're left with 5x equals -1 minus 14. So be careful here. It's already a negative, you're taking away more, so it becomes more negative. So it's -15. It's not minus a -14. There's only one minus sign here. So you can think of that as adding a -14 as well. So it's 5x equals -15. Divide by 5 to both sides. And that gives us x equal to -3. Okay, our last step, as always, is to check our answer. Since we used the first equation to solve for the second variable, we have to check into the second equation. So second equation is 3, and then instead of x, we're going to put -3 because that's what x is equal to. Plus 9 times y. Instead of y, we put -7/3. And is that really equal to -30? Okay, so let me go over here a little bit. Okay, so just evaluate here. 3 times -3 is -9 plus, now I'm going to go ahead and write that as 9 over 1 times -7 over 3. So I can do my math there. Multiply across. 9 times -7 is -63 over 1 times 3 is 3. Okay, and then now -63 divided by 3 is -21. So it's -9 plus -21. Is that really equal to -30? And yes, it is. -30 is equal to -30. And you could have cross-reduced up here too, right here. So if you wanted to, you could have done common factor between 9 and 3 is 3. Divide by 3 is 3. Divide by 3 is 1. And then you get 3 times -7 is -21. Over 1 is just this -21 here. So that would have been fine. Okay, our answer checks out, so we know we're correct. So our final answer, written as a coordinate point, is our x first, -3, and then our y, which is -7/3. Again, we can write that also in curly braces to be mathematically formal there. And then that is our final answer. And that's it. Thanks for watching.